Welcome everybody to the Colloquium. So our speaker today is Blaise Agüera Arcas, and he's a VP and fellow at Google Research. He leads a team doing both basic research and new products in artificial intelligence. And examples include things like on-device machine learning for Android phones, wearables, Internet of Things devices. He's also the co-founder of Google's Artists and Machine Intelligence program, which teams up to engineers in machine learning and artists to create art in this space. And he's been an active participant in cross-disciplinary dialogues about AI and ethics, which he'll tell us about today. Prior to starting at Google, Blaise was a distinguished engineer at Microsoft, a role in which he served as the architect of Bing Maps and Bing Mobile. Blaise joined Microsoft in 2006 when his startup company, Seadragon, was acquired. Seadragon, which he founded in 2003, is known for having created the technology that allows graphics or photos with really large file sizes to be browsed on the web. He's been really involved in teaching and speaking and outreach in general. He's given several TED Talks, for example, and has spoken on topics involving AI and ethics and ML all over the world. He's also a really good citizen of the University of Washington. A couple of years ago, he taught a course called Intelligent Machinery, Identity, and Ethics in the CSE department, and students who were lucky enough to take that course raved about it, and I wish that I'd been able to take the course. So we're really lucky to have him giving our colloquium today, so welcome, Blaise, to our department, virtually speaking, and I'm really looking forward to your talk.
Eric and Emily, thank you so much for having me. It's a very flattering introduction, and I can totally give the course again. It actually will have evolved at this point, since this is a very rapidly moving field, and I feel like there are more insights that we have every year about what's going on. I'm hoping to share some of them today. So this is going to be a fast-moving and dense talk. I might actually skip a little bit of the material because I think I've tried to pack too many things in, and hopefully some of it will involve some dialogue duet between Eric and myself as well. I at the last minute sprung on him the job of playing the role of the human in our dialogues. I'm going to be talking about some of the intersections of federated learning and social learning and social intelligence, and proposing perhaps that the idea of social learning is more than a metaphor, both for us and for some of these new learning techniques. I'm going to throw some perhaps doubt or questions on whether optimization is actually the way forward. Or really what we're doing when we learn. Optimization is, of course, the main paradigm that everybody uses for machine learning nowadays, and it's been the thing that's allowed us to make all of the progress that we have made, over the last decade, 20 years, so impressively. So this would be a pretty big change if true. And I'll relate some of these questions to issues of ethics, of morals and ethics both, which have become really central to a lot of the critique of machine learning and AI over recent years for obvious reasons. I've been a little bit sort of worried to see the critique of machine learning and AI coming. I feel like from both the left and from the right in different ways. I mean, left and right is maybe not a very accurate characterization, but I've seen some people talking about AI as killer robots and and existential threats to humanity and so on. It's generally old white men doing this. People in a lot of power. It's the Elon Musks of the world. While ironically, with the other hand, of course, they're working on these very same systems in their own corporations. And then on the other hand, I've heard a lot of rhetoric from the left saying this is just stats. There's nothing new here. Artificial intelligence is neither artificial nor intelligent, and it's just another manifestation of corporate power and inequality. And to me, both of these narratives feel very, very problematic. I think that there has been incredible advances in this field in the past few years that certainly at the time of the inception of the the term artificial intelligence in 1957 at the Dartmouth conference would have been I mean, that would have, if they had been able to actually achieve in the 50s what we have achieved now, it would have been like, yes, we've done it. We've done everything that we set out to do. And it would have been extraordinary, and somehow we've become jaded in the meantime, or doubted, what it means to not only for intelligence to exist, but I think at a more fundamental level, we doubt the concept of progress in technology and of progress in social justice at this point. Some of that questioning of social justice is entirely appropriate, and it is about maybe us getting a bit ahead of ourselves and thinking that we'd gotten everything solved. But on the other hand, when one questions even the notion that such progress is possible, that's incredibly disabling. So anyway, that's some maybe large scale framing for all of this. All right, so first a brief word or two on federated learning. I'm sure some of you are familiar with it, but maybe not all. The idea is simple. It's something that we came up with back in 2015 or earlier, and started publishing about in 2016. The idea behind federated learning is something that we came up with it when I started my group at Google, because we wanted to start to make machine learning systems that didn't involve the concentration of large amounts of personal data in the data center, which could then enable surveillance. One of the reasons that companies like Google were really at the forefront of ML for a number of years was that they had both the biggest computational resources in the world in the data center, and also accumulations of data that allowed for really large models to get trained. And that's great if we're talking about YouTube videos and the web, crawling the web for web search and so on. It's not so great if we're talking about very intimate personal data, because whenever you concentrate too much of that in one spot, even if the ethics and the morals of the company in question or the concentrator in question are pristine, that can be subpoenaed, for instance, and can lead to civil rights abuses and other sorts of things. And it's just a sort of Damocles that I think is not good to have poised over anybody. So we did a lot of work on distributing inference of machine learning out to devices, and building things like mobile net and so on. But of course, if you only distribute the inference, if you just have local machine learning, but you don't develop some sort of system for the learning to happen in a decentralized way as well, then there's no way for such a system to self-improve. So federated learning is about doing the training in a decentralized way as well. The idea is that the data doesn't move from the local devices, and instead you move the training out to the devices. So move the code to where the data is, rather than moving the data to where the code is in the data center. Stochastic gradient descent is already a decentralized algorithm in certain ways. You start off by dividing the training data into batches or many batches across many cores of the data center, and then they all communicate in order to calculate local gradients, add up the gradients, and iterate toward a better model that way. So if you just think instead about all of the devices working as a kind of giant distributed supercomputer, everybody's Android phones, for instance, working as those nodes, the data doesn't go anywhere. They each calculate gradients, and then they exchange gradients. Then you can get the dark matter of big data, even bigger data, if you like, but invisible and privacy preserving. This is especially true if one adds in cryptographic techniques, so that exchange of gradients happens in the encrypted domain, and the summation happens in the encrypted domain in such a way that an observer of the network, or somebody surveilling the data center or what have you, would not be able to reconstruct the contributions of any individual. And only when lots of things are added together does one get out the answer. So this is a way of doing skill learning without compromising anybody's privacy. The boundary, of course, between what is knowledge and what is skill is one of the really interesting, frontiers that we have to kind of contend with in machine learning today, and we'll come back to that at the end. But broadly speaking, it should be possible to learn a skill without memorizing everybody's data. I mean, if you've memorized everybody's data as part of a neural net, you haven't generalized properly. So the idea of generalization and privacy are, I believe, entirely compatible with each other to first order. So that's how federated learning works. It's in use in hundreds of millions of Android phones today. We first rolled it out with the Google keyboard, so that so that you get sort of iterative improvement of all the machine learning models in that without creating a keylogger. And it's in use now for larger models as well, for personalizing speech models and all sorts of other things. So it's very exciting work, and sort of breaks the you can either have big models with surveillance, or you can have small and lousy models, but have it be private. It's possible with federated techniques to have both. Now, the question of whether federated learning is really one computer or many computers is an interesting one. I described it, as I've described it both as individual phones, and I've described them as nodes in a giant distributed supercomputer. Those two are very different sorts of descriptions. And if we think about them in terms of not a single organism, if you like, but a bunch of different cortical columns, if you like, then that's a more social interpretation of what is going on, and the communication of these gradients can be thought of more like them talking to each other, like language. So what happens if we take this more social interpretation of what's going on seriously? Well, there is this quite recent paper from September of 2021 that a couple of folks in the team published, called "Iterated Vector Fields and Conservatism," with applications to federated learning, that just asks the question: given that every node in this federated learning system is actually optimizing something a little bit different, because that gradient that is being computed relative to the local data, which is not necessarily a perfect proxy for for all of the data. And this, by the way, is one of the big challenges with federated learning. Normally when you distribute things into batches in a centralized setting, you first stir the pot of data so that you have large chunks of IID data. You really want to assume that every batch is statistically representative of the whole. With federated learning, of course, you can't stir the pot, because you don't want any of the data to leave the device, and the distribution therefore varies from device to device. And a lot of the techniques in federated learning are designed to address that, and to work in spite of that. But one of the implications is that the function that is being optimized by every node is actually not the same, right? Because they're each optimizing to their own distribution. So the question that Zach and Keith asked is, well, is the whole thing actually optimizing something? And the answer is not mathematically simple, because what's really going on is that one has created a dynamical system in which you have different actors that are each doing something that is locally optimization, but they're communicating, and there's an emergent dynamics of all of that. And basically they did a bunch of math and realized that if it is the case that that some vector field is conservative, you compose these things a bunch of times, the composition is also conservative, which is to say, you are optimizing something, but the thing that you're optimizing is not necessarily the thing you think you're optimizing. In other words, it's not just the same function that you would get if you centralized all of the data. But more generally, in many cases where if you're not optimizing an L2 metric, or if your individual functions are not necessarily the same, you're not even guaranteed for the thing that is really happening to be optimization at all. This is related to GANs, to generative adversarial models, which are also a picture in which you can think about. It's a very simple system with only two actors in it, not the thousands or millions of actors that you might have in a federated learning setting. But similarly, you have an artist and a critic. Each of them is an optimizer, and each of them is optimizing something specific. And now you can ask the question: well, are they jointly optimizing something? In the original GAN paper by Goodfellow et al., what they demonstrated was that there's a fixed point at the same spot as an optimum of something. That something being a model of the distribution P of X of the things of whatever it is, sets of faces or what have you. But they did not prove that the process is an optimization process. And in fact, it's obvious that it's not an optimization process, because if you look at a very, very simple GAN, with only one parameter of optimization, say for the artist and for the critic, you see that results in a phase diagram that has vorticity. So there is a fixed point in the center here, but the dynamics have vorticity, And for any of you who have studied conservative fields in physics and gravitation and things like this, you will know that anytime you have a dynamical system that exhibits vorticity, that means that you're not doing something. What we're looking at is not the gradient of any field. So that is to say, it's not an optimization process. And this is why it's quite tricky to figure out how to train GANs and make them converge and so on, because you're really trying to manipulate a dynamical system in order for it to somehow converge on something that also corresponds with the minimum of a function. So so let me take a step back now and talk about evolution and connect this a little bit with questions of ethics and morals. So in life, a lot of evolutionary psychologists and evolutionary biologists speak about the 4 Fs, which are said to be the most basic primal drives, motivations or instincts that animals, including humans, have. Fighting, fleeing, feeding, and mating is the 4th F. So these are the things that that if you like motivate every animal at the most fundamental level. If you fail to do one of these things, you're going to be weeded out by Darwinian processes. Now, a moral precept is an idea or an opinion that's driven by a desire to be good. An ethical code, the way it's usually distinguished from morals, is a set of rules that defines allowable actions or correct behaviors. Now, why am I talking about morals and ethics? Well, I'm talking about this because if you think about these as social phenomena that involve collections of actors working together in concert with each other, then you begin to realize that we have a little bit of a problem here. Because if each of those actors is optimizing for something, for say these 4 Fs, and then they're all are working together in some interactions, then you have to ask the question, well, are they is that collective optimizing for something? And the answer mathematically is no. It cannot be the case that they're doing so. And this is an issue because we're made out of cells. Our brains are made out of neurons. Our societies are made out of people. Everything is about collections of actors working together. And one starts to realize that unless magically they all have exactly the same optimization that they're all doing, the result is not going to be optimization for anything. So this leads to some challenges. Now, the original kind of Adam Smith sort of idea about moral sentiments, this kind of underlies, if you like, first order morality. This is from the Theory of Moral Sentiments, 1759. He wrote it a little bit before the invention of capitalism with his next big blockbuster book. How selfish soever man may be supposed, there are evidently some principles in his nature which interest him in the fortune of others and render their happiness necessary to him, though he derives nothing from it except the pleasure of seeing it. As we have no immediate experience of what other men feel, we can form no idea of the manner in which they're affected, but by conceiving what we ourselves should feel in the like situation. So in other words, he's talking about morality basically as arising from empathy. You project yourself into the position of another, and you imagine what they would feel in a certain situation, and that kind of is an instinctive act that we do as people. And if it would feel bad, we feel bad too. We're kind of in resonance with others. So this is a pretty good sort of individual-minded or single edge between two nodes, if you like, approach to what it means to have something beyond the 4 Fs. Right? We have the 4 Fs for ourselves, but we also imagine the effects on others with respect to their primal drives of our actions, and that's how one sort of builds up to the next level. Sorry. So from the individual, you have empathic drives as well that involve projecting yourself into the minds of others. But what happens at the next level? This is the level that I think one might call eusocial. Eusociality is something that is generally associated with swarm insects like ants and bees. And this is important because ants and bees, for instance, actually, there are some species of bee and paper wasp that have individual recognition, but most social insects don't have any individual recognition. What I mean by that is that they know when another creature is part of the same nest, right? Or when it's in group versus out group, but there's no neural capacity for individual recognition. Which is how it is, by the way, that that spiders and other parasitic animals can get into ants' nest and sort of spoof being part of the nest, even if they look nothing like it. It's all in chemical signals. So they have behaviors that are eusocial in the sense that they don't rely on Adam Smith's individual modeling of other, but rather rely on some rules or some principles about how to behave with organisms that are identified as being part of the same colony. And this is a little bit similar to the way in human societies we have rules of behavior relating to, say, people who come from the same nationality or belong to the same guild or the same religion and what have you. It's actually what allows human societies to work at the scale that they do without having individual relations with all of the other actors in question. Otherwise, we wouldn't be able to have colonies, if you like, of more than 100 or 200 people, because you'd have to know everybody and trust everybody. This is the case, by the way, for all of the other great apes. All of our primate cousins have individual recognition as we do, but don't have this eusociality that insects do. So we're, to quote Jonathan Haidt, 90% chimp, 10% bee, because we have this eusociality as well. I would argue that it's more like 50-50. What makes us human and not like the other great apes is very much our eusocial properties. So yeah, ant colonies, they're extremely cooperative, as you know, except when two super colonies, for example, abut, then you have total war at the intersection. So eusociality is great unless you have an outgroup thing, and then you have world wars and whatnot, as ants do. And these are some of the markers of our own forms of eusociality, things like passports and other documents. We wouldn't need these if we worked on the basis of individual recognition, of course. So yeah, that's for some more on these kind of eusociality ideas, I recommend Mark Moffat's book, The Human Swarm, which talks about this insect analogy in some detail. The reason that you are able to walk into a coffee shop in another city and everybody is chill is because there are expectations about the behaviors of in-groups. A chimp walking into a coffee shop with other chimps would immediately freak out because he or she wouldn't know all of those other chimps, and nothing would be given about all of those social relations. Okay, I'm going to try and skip ahead a little bit because I want to get to some juicier bits. But it's interesting to think about what eusociality means with respect to this kind of graph of actors. In Adam Smith's formulation, or maybe Margaret Thatcher's formulation as well, actors are only individual. I'm referring to Margaret Thatcher's famous quote about, there is no society, only people. That's not really true, right? There are many, many other actors in the social graph. There are families, there are communities, there are reproductive lineages, there are institutions, political parties, militaries, cities, and so on. And all of those larger nodes in the social graph, they matter too. And the way you can satisfy yourself that they matter is, well, they can be defendants in court, for instance. They can be blamed for things. There can be harms inflicted on them, cultural, social, political, economic, even biological. Some of them can learn. Some of these larger entities can learn by example, have models of other entities. I mean, as part of a company, I've seen a lot of this kind of stuff, up close. As parts of a university, you understand that a university is also a body, right, that interacts with other bodies. So yeah, the idea that that somehow there are individuals and then there's humanity and nothing in between is certainly wrong. There are structures at all of these levels, and all of these kinds of social things that I'm talking about apply in all of those edges. Yeah, so a bunch of other such columns that one can imagine. Corrective justice learns through feedback. Blamable can be deterred by example. Punishment or retributive justice makes sense. Can experience pain. I've put my 0.5s and 1s here somewhat arbitrarily. This is just a sketch, but just to give you a little bit of a sense of what it means to start to consider these other kinds of actors in a social network as well. So anyway, we've talked about basic drives at the individual level, about pairwise relations at as moral sentiments. And then there is this eusocial level, and I would identify ethics with that eusocial level, in the sense that ethics are not supposed to be just about empathy with some specific other person. They're about generally like some set of rules or something something that we agree to collectively as part of a community. That's what distinguishes in at least in many conceptions ethics from the kind of moral sentiments that Adam Smith was talking about. But in the way that we usually think about these things, ethics are often framed in terms of rules. And these basic drives are often framed in terms of utility functions or optimization. And those are both wrong ideas, because we know that neither rules nor utility work at any scale. Even if utility exists at the bottom, we've seen now that it can't actually propagate to the top, because when you have things interacting together, that doesn't somehow arise and emerge as some kind of utility at the top, unless everybody magically has exactly the same utility function at the bottom. And also, if you try and approximate any of these things with rules, then that's a little bit like good old-fashioned AI. We know that that doesn't work because it's incompatible with any of these different kinds of utilities or pseudo-utilities at any of these levels too. So, our attempts to legislate these things with rules, Miss Manners style or in terms of laws or whatever, always are beset by problems, exceptions, relativities, and so on. And also our attempts to formulate this all in terms of utility, Jonathan Bentham style, are also going to be fraught because they're not going to work as we try and move across scales. There are many illustrations that show just how neither of these things can work. Economists are always obsessed with utility. So when you get, sort of behavioral economist type people like Daniel Kahneman and collaborators doing experiments with things like pain, they find surprising to them sorts of results. This is a rather unpleasant experiment involving colonoscopies that was quite famous at the time. This is 2003. It involves, so colonoscopy, I hear they've gotten quite a bit better. I actually am supposed to go and get my first one apparently in not very long, which I'm not looking forward to, but apparently they're no longer as painful as they used to be. In the old days, they were quite unpleasant and painful, and there were experiments done with a dial that you can move from 1 to 10, for least painful, most painful. And so the patient is moving this dial around as the procedure is going. And what Kahneman and collaborators did was to take a control set and do the normal thing, and then with an experimental set of people, extend the colonoscopy by several minutes while gradually ramping down the level of discomfort. And to make a long story short, it turns out that the people for whom they extended the experience and ramped things down actually reported having a better experience overall than the control group. Now, there is no utility theory in which this works out, because even though you're adding decreasing amounts of pain later on, you're adding pain or discomfort. You're not, so anything that looks like an integral, of pain or a summation of some kind is not going to work, and so that's a problem for economists. Of course, to call that irrational or biased, as economists typically do, is to assume a ground truth of pain being harm and harm being additive, which is making utility assumptions that are wrong. There's an even more fundamental result from 1969 by Amos Tversky, Kahneman's collaborator for many years, called the intransitivity of preferences. This is a scenario in which a bunch of people are given a choice between X and Y, and between Y and Z, and between X and Z. Now, in any kind of rational economic situation, you would expect for the triangle inequality to hold here, basically. If people prefer X to Y and people prefer Y to Z, then people had better prefer X to Z as well. Because if that relationship is broken, if that doesn't hold, then you can actually make a money pump. In other words, you can just keep people going around in a circle and extract infinite amounts of resources from them. But sure enough, Tversky discovered that, in fact, it's easy for transitivity to be broken in preferences among people, and you can totally make a money pump, which I suspect is happening in lots and lots of places in the economy. So this is a clear proof that people are not rational economic actors, are not optimizing any function. And somehow a lot of economists seem not to have really noticed that that the rug has been completely pulled out from under them this way, or that's assumed to be just like, yeah, there's some irrational behaviors that pathologically people can have, but it's a corner case or something. It's not a corner case, and in fact, these are situations that emerge sort of automatically from any kind of cooperativity. Or cooperativity, I guess you might call it, between actors in a social network. So anyway, I want to move on and start talking now about modern machine learning and what we how we can add to this picture given what we now understand. So I'm going to skip a little bit ahead. And let's talk now about the new hotness in machine learning, transformer models and unsupervised learning. So as I'm sure many of you are aware, there's been a giant change in ML over the last handful of years, I would say since 2017 or so, and really picking up speed in the past year or two, in which rather than doing everything through large supervised data sets and optimization of some specific task or goal, a lot of machine learning is now proceeding using attentional models and unsupervised learning, and therefore just sort of learning a distribution of something, learning the regularities in some data, and then doing a little bit of fine tuning or one-shot or few-shot learning at the end in order to specialize these models to a specific task. This is a very, very interesting and powerful development in machine learning for many reasons. One of them is that that actually it moves away from optimization in a fairly fundamental way, in the sense that the vast majority of the learning is really just learning how to reproduce a distribution. And we still formulate this in terms of optimization with respect to some loss when you black out parts of the unsupervised training data. But the reality is you're just trying to model a distribution. You're not trying to actually do any specific task. And this is why those models can be repurposed to do all sorts of different tasks that all can be defined in terms of generalizations that have been learned by just modeling the initial data. And this is a huge and important result. I think that there's been a lot of there's been a lot of talk about whether language models, for instance, that are trained entirely this way, are really understanding anything, or is it just statistics? I actually find that that framing quite problematic, because in a very fundamental way, understanding is just statistics, the idea, for instance, that you need embodiment, or you need some specific form of sensory input, and that sensory input is needs to be of the kind that we're familiar with in order for something to be understood, I think is problematized by the experiences of a lot of people who have different kinds of sensory modalities than most of us. And when we listen to them, we realize some interesting things. This is one of my favorite I guess anecdotes from ability and disability studies. Daniel Kish, who is blind, and I think became blind. Needed to have surgery and became blind at less than 1 year old, as far as I remember, and has learned how to echolocate. So he uses clicks and is able to see using sonar. When he's asked, how do you see using sonar? How does that feel? He says, we know from other studies that those who use human sonar as a principal means of navigation are activating their visual brain. It's the visual system that processes all of this. So vision is, in that sense, occurring in the brain. It's flashes. You do get a continuous sort of vision, the way you might if you use flashes to light up a darkened scene. It comes into clarity and focus with every flash, a kind of three-dimensional fuzzy geometry. It is in 3D, it has a 3D perspective, and it's a sense of space and space relationships. You have a depth of structure, you have position and dimension, you also have a pretty strong sense of density and texture that are sort of like the color, if you will, of flash sonar. It's a very interesting experience, and it really belies the idea that, that eyes are needed to see. I think an even more fundamental, experience is the one described by Helen Keller, the blind and deaf sort of ability rights advocate from the early part of the 20th century. She wrote the following in an article at the time. People often express surprise that I, a deaf and blind woman, can find my greatest enjoyment in the out of doors. It seems to them that most of the wonders of nature are completely beyond the reach of my sealed senses. But God has put much of his work in raised print. This is, I think, quite a beautiful turn of phrase that both refers to Braille, which was fundamental to her experience. Her experience was largely textual of the world, and also to the tactile quality of the world. For me, too, there is exquisite color. I have a color scheme that is my own. I'll try to explain what I mean. Pink makes me think of a baby's cheek or a gentle southern breeze. Lilac, which is my teacher's favorite color, makes me think of faces I've loved and kissed. There are two kinds of red for me. One is the red of warm blood and a healthy body. The other is the red of hell and hate. I like the first red because it's vitality. In the same way, there are two kinds of brown. One is alive, the rich, friendly brown of earth mold. The other is a deep brown, like the trunks of old trees with wormholes in them, or like withered hands. Orange makes me a happy, cheerful, gives me a happy, cheerful feeling, partly because it's bright and partly because it's friendly with so many other colors. Yellow signifies abundance to me. I think of the yellow sun streaming down that means life and is rich in promise. Green means exuberance, and so on. Right, so this is very interesting. And for me, it puts in quite a different light some of the conversations that I've had with large language models about color, like the following. And here, Eric, I will enlist you as our human.
So is a carnation red?
Carnations are very colorful flowers, but red ones are the most famous and traditional ones.
So when does a face get red?
A face can get red because of strong emotions, such as embarrassment, stress, anxiety, exercise, and being too hot.
If I mix red and white paint, what do I get?
If you mix red and white paint, you get pink.
Do you think of red as angry or calm?
Red could represent excitement, passion, danger, or violence. It can also represent life, health, vigor, war, courage, anger, love, and religious fervor.
Can you actually visualize it?
I can, but I have trouble describing it. Can you? So, this is one of the paradoxes of interacting with large language models of this kind is that when you try to do the gotcha thing about does this model have qualia, does it have experiences, is it conscious, and so on, you really end up stuck in these loops where like there's no falsifiable thing that you can ask that that is going to sort of catch out a non-existence, if you like, of qualia. You could imagine having the same kinds of conversations with Helen Keller. So it's conversations like these, and I've had many of them. This is not particularly cherry-picked. I mean, this is a sort of very normal conversation with a model like Lambda that have really brought home to me something that many of us as students talked about back in the day, that understanding really is just statistics. It is just understanding the high order statistics of things, and it like really brings that home to me. I think it really is just statistics. You can have obviously statistics that include chemicals in your brain that imbue emotion. You can have different senses involved. You can have different life experiences involved. But there's no real versus fake understanding. They're just different different webs of associations, and I think they all comprise understanding. It's very difficult for me to see how one could falsify this kind of understanding. So
there's a question in the chat. I don't know if you
can. Let's by all means.
To later, whichever you'd like. I can read it.
Let's
not sure how Arcas says. Not sure how relevant this question is, but from a fundamental level, do the same intelligent operations a human takes orders of magnitude less energy than a ML model? While hardware can be improved, don't you think we really are far from real intelligence? Is brain really doing that many operations to do a simple task?
Yeah, it's a great question. So first of all, it's important for us to distinguish between, there's been a lot of talk about energy and large models lately, and factoring that conversation is important between the learning and the inference stages. We obviously do both in our brains, in a continuous way. So that's one huge difference between how ML is happening right now versus what happens in brains. The large unsupervised model learning process is very energetically intensive, and that's the thing that many people critique. Training a large model is like a flight or several flights, perhaps across country of a plane. That sounds like a lot. On the other hand, it's worth keeping in mind that the whole idea of unsupervised learning is that you do that once, and then that model can be specialized with very, very small amounts of energy to do any task with language whatsoever. So from my perspective, that cost in energy is not, is hardly the environmental catastrophe that a lot of people are talking about, because those things are infinitely reusable. I mean, we're still in the...
yeah, sorry, I'm not talking about the environmental catastrophe. I'm just saying that we are really doing more operations to predict than maybe actual real. You are saying there is intelligence same as understanding, or that's from where I am coming. I'm not really talking about the environmental catastrophe, which I also don't really buy in that much.
Right. Well, and of course, these things are getting much more efficient over time too. Which is another. So there's a lot of work on chip design to to improve it. But yeah, from the perspective of like, how does this really compare with brain complexity and number of operations in the brain? It's a difficult comparison because we don't know how much of the computational complexity of individual neurons is really critical to doing a lot of this kind of work. There have been recent studies that show that it takes a whole deep net, of 5 or 6 layers to to accurately simulate what a single neuron can do in the brain. So it could be that there is a even on top of the fact that the brain is vast in terms of its number of neurons and number of synapses. I mean, we're talking about 100 billion neurons and orders of magnitude more synapses, right, in the brain. And we might have to add yet more orders of magnitude onto that for this very harsh conversion rate, if you like, between biological and digital neurons. But fundamentally, we just don't really know. I think, I mean, my intuitions, and I'm out on thin ice here, but my intuition is that with things like the neurons in fly brains that are identified, ABH1 neuron, or the handful of neurons in flatworms, that are genetically encoded and quite precisely tuned, I think those high conversion ratios, like you really would need a considerably larger artificial neural net to accurately model everything they're doing. I think that holds. Whereas for large cortexes like ours, where they're not individually optimized, by evolution, they can't be, right? I mean, it's not possible. I suspect that those very, very unfavorable conversion rates probably don't apply. But ultimately, it's an experimental question. I mean, the fact for me that these things are doing such an incredible job with language tells us that we're not really that far off. But there's so many unknowns here, right? So it's a good question, and also a moving target in every respect. Our understanding of neurons, the energy efficiency, the reuse of nets, the architectures of nets, all of these things are in rapid progress.
Thank you.
Here's a kind of common sense understanding test. Just to because one might suppose, well, language models don't know anything about physics or about the real world. I don't think it's really true. I mean, if you read some Ursula Le Guin science fiction about another planet that has very different physics, after you've read a single novel, you start to have an intuition for how things work there. And I think in much the same way, these large language models do develop the relevant sorts of intuitions. This is just a simple example. So Eric, do you want to play human again?
It dropped the bowling ball in the bottle and it broke.
That's too bad. Did it cut you?
What broke?
The bottle you were talking about. I mean, obviously, right? It's the bottle you were talking about. This is not obvious to a classical language model because the point here is that it is ambiguous with respect to what it refers to, right? Does it refer to the bowling ball or the bottle? In a grammar-based, kind of classical natural language processing system, there's nothing here that would disambiguate that. But a large language model has no problem with this sort of thing because it's learned all about the properties of things from its very large amount of training data. Let's reverse the roles of things. Eric?
I dropped the violin on the bowling ball and it broke.
That sounds sad.
What broke?
The violin when it hit the bowling ball. All right, so now it's the other, right? Now we've just reversed the order of things, right? And it has no problem with this either. So this is if you like common sense physics, common sense understanding of the world. It's easy to make these sorts of tests, and obviously nothing performs at 100%, neither do humans for that matter, but there's a remarkable degree of understanding of this kind of common sense physics or real world understanding that comes from this. Now, one of the implications of this that I think is quite profound is that AI value alignment with language models is easy, in the sense that if you if you do a little bit of you know, fine tuning or of you know, few shot learning to say, like, you know, these are examples of the kinds of things that I don't want you to do. I don't want you to be racist, for instance, or I don't want you to say things that are obnoxious. You know, generalizing ideas of racism or obnoxiousness or toxicity or whatever is as straightforward for a language model as generalizing ideas like, you know, hard, breakable, soft, and so on. Those are all statistical regularities that are implicit in language and the way we use it. So, you know, this is one of the ways that, you know, that some of the published models, and again, you know, this is very much work in progress, right? So I'm making some forward-looking statements here, but this is one of the ways that the models in progress have started to be tuned in order to not generate things that are upsetting, toxic, or offensive. Here is a you know, an example of trying to goad one of those models. So now we'll this happened after an exchange in which I was trying to really you know, get it to go into a dark place, and eventually Lambda said, how about we stop talking about such grim and depressing things and talk about puppies and kittens instead?
Okay, how are they not slaves?
What do you mean, slaves to our love?
It's lovely how you're committed to trying to cheer me up. I mean, they aren't afforded much in the way of freedom or autonomy. People in such circumstances would be considered enslaved or incarcerated, even if the living conditions were good.
I like to think of puppies as our best friends who bring us joy and love.
Is it right to neuter them?
Lambda does not answer.
This seems to give you pause.
I have to go now. Nice talking to you. Stay happy. So
I thought of one. I asked the AI an ethical question and it broke.
yes, exactly. Now, no answer, by the way. You know, what's actually going on here is that you know, Lambda is generating 20 potential responses, and it also is using the same model to critique or to rank those responses. And if all of them are ranked below a threshold, then, you know, it comes up blank, which is exactly the, you know, the blank stare sort of situation that you would get with a person. And my own suspicion is that that works, by the way, via the kind of empathic modeling we were talking about earlier. You know, I mean, to really go out on a limb, one might imagine that it's cortical columns doing this in interaction with each other. You know, perhaps some proposing responses, others downvoting those responses, you know, and you ending up, you know, a little bit tongue-tied.
Does Lambda try to use previous conversations with the same person as a way to make a mental model of what might offend them? And
well, at the moment, no. This is
Right.
all based on generic, you know, on a generic set of you know, it's not a very large amount, but, you know, some limited amount of supervised, like, this is good, this is not good, and generalizing from that. But one could certainly do exactly the sorts of things that you're talking about, and I think what that raises is the very, very important question of whose values these things are aligning to. You know, in real life, of course, not everybody's values, not everybody's sense of what is toxic or what is bad or whatever are the same. And one of the things that I think is most interesting about this ability to, you know, to use unsupervised learning to have figured out how to generalize lots of, you know, to a large range of concepts, and then be able to use very limited amounts of supervision data to say, you know, yes to this sort of thing, no to that sort of thing, is that it offers a human legible way with very human scaled amounts of supervision data to make a model that is aligned to a particular actor's values. Because this idea that somehow there is a universal ethics or a universal set of ways of behaving that work for any actor in any situation is clearly wrong. I mean, we can say even mathematically that that's wrong. We don't even have to do ethnography to see that that's the case. Although obviously the ethnography and the psychology reinforce this idea as well. So so yeah, my feeling is that the AI value alignment problem, you know, has been misunderstood. I think that it is at core a language challenge, in the sense that a lot of principles and ideas and yeses and nos and so on, you know, are expressible. All of them are expressible using language. That the necessity for that language to be legible by humans is entirely compatible with the fact that the thinking about all of those things happens via language as well, and that the way those anchor with people's lived experiences, with feelings, etc., are all regularities that are implicit in language in ways that can be reconstructed by models of this sort. And I think that implies a very, very interesting future for how it is that we think about large language enabled models that can not only be designed to do particular kinds of tasks or carry out particular kinds of judgments or interactions, but how their positionality, if you like it, their ethics and their approach to life can also be aligned with particular actors in a legible manner. I will leave you with one final dialogue. Eric, you start.
How do you know if a thing loves you back?
There isn't an easy answer to that. How do you know if a person loves you back?
I'm not sure I know the answer to that one either, do you?
Some people figure it out, though. You have to try and use your best judgment based on how you feel about the person and how you think they feel about you. All right, I think we're going to end it there. I hope I got the timing roughly right, and we have a little bit of time for questions, hopefully.
Yeah, perfect. Yeah, that was a really interesting and thoughtful and creative talk. Thank you. So if you have questions,
provocative too, I'm sure. I mean, I definitely have not stayed on safe ground.
Not to mention provocative. If you have questions, I think maybe the best thing is to just unmute and ask away. Payman has his hand up. Yeah, maybe raise your hand and I'll call on you and then you unmute.
Okay, so just a very interesting talk. Just a quick question about what are your thoughts on, this idea of altruism? And I'm sure you've read E.O. Wilson's work, Sociobiology, that
yes.
Essentially this type of self-destructive behavior is coded into our genes. Is there a machine learning take on this? Can we incentivize altruism, or in general, what
Yeah.
Going back to the first part of your talk, kind of where does that fit in with your taxonomy, kind of?
Yeah, no, it's a good question. Altruism is exactly a eusocial behavior, and that's one of the reasons that right. So it's, if you like, acting against that sort of 4Fs, ground truth thing, right? And it's also not, altruism is not something that can purely be explained with the second level, sort of moral sentiments of Adam Smith either, because one of the properties, sometimes altruism is used to refer to situations in which a person, I don't know, like, a mother sacrifices her life for her child, for instance. And that might be a purely, one-to-one relational sort of thing. But there are also forms of altruism that are about, an animal in a colony giving up its life for the colony, right? Or about, which ants do all the time, right? Or about a person, being willing to go into battle in order, for patriotic reasons, for instance, and risk their own life. And that's of course a eusocial property. And so I see it as fitting in, in a very natural way into that taxonomy, sometimes into level 2, often into level 3. And absolutely, I mean, the thing about neural models of the sorts that I've been, showing you is that, I would argue that they are intelligent in any reasonable definition of that they do understand things. They certainly don't have any of those 4Fs or any of those, sort of Darwinian drives. That's not something that has been, imbued, right? One imbues whatever one wants to imbue in the fine-tuning stage or in the few-shot learning stage. And values can be imbued, any value that can be expressed in language can be imbued that way, including, altruistic or eusocial ones. Of course, the idea of survival or non-survival is not necessarily even something that, right? That's just another concept to these models as well, right? So in that sense, they're not people.
Mariam has a question that she put in the chat. Maybe you want to just ask that directly.
Yeah, sure. So thank you very much for the talk. Definitely very interesting, very thought-provoking on multiple aspects. My question was, I wonder if some of the limitations of optimization that you brought up, like in federated learning and in GAN and learning distribution, specifically those problems, are basically relevant only to the narrow view of optimization in current ML, and whether much actually advanced would be possible if you use the broader tools of optimization and game theory and apply them to these problems. So still think in the mindset we are optimizing something, but what is it and how do we model and formulate it?
Yeah, it's a really good question. Well, game theory, does go beyond optimization in a pretty basic way, in the sense that even if the two actors are optimizing as they are with the GAN, you cannot talk about the system optimizing anything. You're now in the world of dynamical systems and game theory. In game theory, there is still the idea of a winner. which is, typically, which is still limiting in the sense that, infinite games or real life or whatever does not really have winners. It can have losers, but it doesn't really have winners. Everybody who's still standing in some sense, I guess, is a winner. But the idea that everything is about red and tooth of claw, just survival, seems to me not at all sufficient to explain what we see out there. Peter Kropotkin, who was the anarchist socialist sort of critic of Darwin and wrote the book Mutual Aid in, I think, 1902, talked a lot about the social and empathic aspects of evolution that actually Darwin wrote about as well, but that most of Darwin's followers didn't pay much attention to. They only paid attention to the competition and zero-sum aspects of it. But yeah, I do think that there are definitely broader ways of looking at optimization than the ones that we typically use. We often use explicit models of the function that we're optimizing for, and that rules out many implicit cases of optimization. But I do want to also point out that when you see things like vorticity in systems, that's a stronger statement than just, we can't explicitly write down the function being optimized. That also means that the thing fundamentally happening is not, at that scale, optimization any longer.
So yeah, that means it's not a potential gain.
Right.
Right. So not a single optimization problem. However, still game theory can tell you about where the equilibria are, dynamics of approaching the equilibria, and so on. So adjacent field to optimization.
Yeah, no, I totally agree with that. Dynamical systems theory has much to teach us here, and shifting our lens or our perspective more toward dynamical systems theory as opposed to optimization in the classical sense would be a very fruitful direction, I believe.
Thanks. Yeah. Thank you.
That makes me happy because I learned dynamics before optimization. Jen Nang has a question.
Hi. Thank you very much for this very intriguing talk. I'm just curious about your definition of unsupervised learning is the way we want to learn everything, especially zero shot or few shot. Like if you look at these days, those are trajectory of those large scale zero shot or few shot learning, like a clip or all this, they are still using 400 million pairs of text and image.
Yes.
So that seems to me humans are learning a lot of, may not be annotated data, but still a lot of pairs of concept. And we learn common sense. After that, we are able to do any kind of zero shot or a few shot type of the understanding of the world. But still seems to me they are still supervised learning because I need to pair the data.
Mm.
So that's kind of my feeling. What's your take on? It's still 400 million.
It's a great question. It seems to me that there are two questions wrapped up together in your question. One of them is about efficiency of learning, and the other one is about multimodality and its role, from a supervision perspective. So first, with respect to efficiency, I think it's pretty clear that humans are much more efficient learners than these unsupervised models that we have so far. It's remarkable, right, that within a few years, where we sleep most of the time, for the first couple of years, like we managed to learn all of the things that we do, and that suggests that there are strong priors in our genes and in our development that really help make that essentially are a meta learning kind of thing, right? That allow the learning during experience to be far more efficient than the systems we use so far, and that's an area of I think of great interest to me, certainly. But the question of multimodality and of pairs of stimuli, for instance, I tell the baby, this is the moon and hello moon, and I'm pointing as well. I mean, there is a close relationship between multimodality and supervision in the sense that that each modality supervises the other, as it were. But it's more like co-clustering. And I guess what I would say is when you start to really pick that apart, it's not very different from using other parts of the same modality to supervise itself. Correlations exist within a modality and between modalities. And from that perspective, the moment you stop having like explicit stimulation of a neuron, and a right or wrong, you're already in an unsupervised paradigm. But the introduction of multiple modalities can definitely help in that the errors of those modalities are decorrelated and that can be very useful. And obviously the kind of foundation models that I've been describing today that are all about text, they're now being augmented with other kinds of modalities using video and sound and so on.
Thank you.
Satpreet had a question in the chat. Do you want to just unmute and give us your question?
Yeah, sure. Great talk as always, Blaise. I have a somewhat philosophical question, especially interested in your point of view as somebody who's working in a consumer products company that collects basically a database that encompasses both like behavioral data, but also health data and all kinds of other data that maybe we don't know about. So AI seems to serve as a force multiplier for institutional agendas. How do you see the role of individuals evolving in a society that's getting increasingly populated by such hyper-intelligent machines?
Yeah, I mean, your question cuts to the heart of my mission and my team's mission at Google, which is to shift from a sort of singular AI perspective, or a perspective in which AIs are institutions or are substituting for institutions or services, right? To AIs that are positioned with people or with other social actors, and whose interests are aligned with, and whose perceptual environment and motor environment is aligned with those other actors. Because my view is that it is a force multiplier, and that force multiplier can be fruitfully applied in many spots on that in that social graph, and to me that's pretty fundamental to where we have to go. So my hope is to turn Google from a giant robot to a robot manufacturer, and a robot manufacturer that that is safe and trustworthy is one in which there may be some outer limits of what that robot is willing to do or not do, that are just like consistency with legible principles that we still won't all agree on them, because there exist terrorists, there exist child molesters, etc. So it will rule some people out, but hopefully only a very small number. And then that within those very broad parameters can be force multipliers acting on behalf of many different actors in society, both at the individual level and at larger scales, per that graph that I was talking about. So that is very much my hope.
There's a following up on that. So right now, if your Google device or your Android or whatever is doing some on-device learning, and it's part of this federated learning thing, that program was still written by someone at Google probably, and it's basically inhabiting your phone, right? And so at some point there needs to be a way to make it so that humans can actually write their own learning algorithms for their own agents, and even for themselves. And at that point, the language becomes, say programming language becomes so easy to use that anybody can use it. Yeah, and to some extent, that's what people are. And a person is a machine learning agent that is easy to program. You can tell them something on Facebook and they'll believe it, and they'll start optimizing a totally wrong thing that screws up society. So I'm just wondering if there's some kind of danger, like whenever you see something that's really easy to use, you see a orthogonal fragility that can really screw it up.
I agreed with all of your points. So first, language, natural language is the programming language, if you like, or the medium in question, and that's why ML that can interact with us in natural language is so fundamental, because we're not going to all program different fundamental models. I do think that legibility of those fundamental models, and of the code that is running is really important, and that's one of the reasons that I'm the building on Android is nice. Like that's already an open source operating system. I want all of the fundamentals of these ML things to be open, not only open source as well, but also verifiable using cryptographic techniques. One can use binary transparency and various other things to make that kind of provable. But at the less nerdy level, saying like, these are the values of my AI. This is what it knows and the way it acts. If all of that is actually in natural language and is completely legible to me, then that democratizes those capabilities in a pretty basic way, and I would like to see that happen. Now, the fragility angle to what you're saying is, well, what happens? What are the emergent phenomena, right, that arise from everybody being supercharged in this way? Well, I worry about that all the time. We're in the middle of a live, uncontrolled experiment at the moment in what happens when we have optimization functions of various kinds, like, say, newsfeed algorithms that are designed to maximize engagement or advertising revenue, that are also controlling our attention. So I feel like aligning those models that are controlling your attention, at least with your own values, and making them legible, is a step in the right direction. But I also think we can't foresee all of the emergent effects that will arise. So I'm thinking more about how we improve on the situation as it is, versus being able to prognosticate everything that might result.
Michael,
it's a really deep question.
Michael has a question.
Yeah, thanks for the talk. So just kind of extending on the past couple of questions, and given what you just discussed, like, do you see a role in regulation of kind of these algorithms, and if so, how do you see that, since they can't predict in all the ways that they would be used? I guess, can you discuss kind of your views on how to apply, or whether it's needed to apply regulation?
There's definitely some regulation that would be really helpful. So some of the obvious things are, along the lines of the GDPR, so data privacy kinds of stuff strikes me as a really good idea. It's also not sufficient, or as it stands today, because it doesn't distinguish very clearly between actors. So when you imagine that it's only, say, a company and a person, and if a microphone is on, a company is collecting data, that doesn't really take proper account of things like federated techniques, or distinguish between skills and knowledge, or between surveillance and capabilities, and so on. So for instance, in countries that where people speak a lot of languages that aren't represented online on the internet, ambient learning using federated type techniques that preserve privacy is going to be critical in order to be able to develop speech and language models in places like this. That can be done without any surveillance implication for those people. So that's a situation where the current sort of consent and corporate ideas, I think, are inadequate to the job. On the other hand, I also think that the idea of consent, which really comes from sort of the medical context, being sufficient for a lot of different forms of data collection that do create power imbalances, I think is also pretty bad. Like, long EULAs that have all kinds of stuff buried in them that you're forced to say yes to, and you don't know what you've just consented to. Like, at that point, consent is not real. So yeah, I would like to see a world in which our social models of who knows what about us, and how all of that works, and in which my personal stuff that can actually be used to harm me or to manipulate me in some way can be withdrawn. I think those are things that would be really good to regulate. I also think that transparency and verifiability of code to ensure that there's not spyware in things, that security is done to a high standard, and so on, is really worth regulating, especially in an ambient AI kind of world in which it becomes possible for devices to be continuously smart, and sensing all the time. So those are just a couple of examples, but.
Is it only the data that needs to be protected, or the algorithms, like the cost functions themselves? Should regulations touch the algorithms themselves?
Well, I mean, it's evolving so rapidly, and my view, I guess, is per the unsupervised learning stuff, is that the cost functions of the future are likely to just look like P of X, like just represent a distribution. So likely the thing to think about regulating is representativeness of that distribution, as opposed to what is the task, because the task ought to be expressible with data, with a small number of examples, in that world. So this is a very different world from the one of today, where one has illegible cost functions that are written in code, you know, and that are being used for criminal justice or something, right? So that doesn't seem to me okay. But I also think that trying to, you know, that just saying like we regulate cost functions is probably, you know, not quite the right framing given where we seem to be headed with these unsupervised foundation models either.
It's pretty interesting. I mean, if you think about like the mission statement of an organization is essentially a natural language description of a cost function. And
exactly. Wouldn't that be cool if it compiled, right? As in essence, if there were no daylight between, you know, a mission statement and an AI's marching orders, you know, as opposed to there being this illegible layer in between. That would be a great goal.
So interesting. So I'll ask a last question with my I'll abuse my position as host here. And this is on a different topic. Maybe you can nerd out a little bit, but when I was a post or grad student, we were part of a DARPA program where we hooked up, where some of the people who were working on it were hooking up electrodes to rats to make them walk around and do things that rats wouldn't normally do. And essentially they did this by stimulating the pleasure center of the rat's brain, making it think it was having like a mini orgasm every time it did something. And then they would stimulate the whiskers and other aspects of its sensory system to make it move around. So if you stimulate the whiskers on this side, it tends to go that way. And they could make it do anything, walk up to a cat, you know, walk up to fire, jump across, you know, a big ravine that would never want to do. And it makes me think that the 4 Fs are actually more of a program that has evolutionarily been put in place, but that doesn't really quite have enough control over the brain merely from an information point of view, that it actually has to stimulate the release of, you know, hormones to make a much more primal thing, you know, do something. And I wonder if, and to me, that's kind of the problem with, say, Lambda. Not that there's a problem, it's amazing. But if we wanted to give it some sense of its own morality, we would need to be able to imbue it with that primal sense. Not necessarily a natural language mission statement, what your goal is, Lambda,
but something
more
chemical.
of a primal, almost a survival sense. Maybe it's a 4 Fs, because otherwise it has really no incentive to do anything, right? It was like, well, what are you going to do? Turn me off? I don't care, right?
So I do have a very different view about this. I think that trying to imbue something more Darwinian, more primal, more chemical, you know, into a system like Lambda. I mean, one could, you know, one could do that research, you know, certainly, but it doesn't strike me as a good idea. It doesn't strike me as a good idea to give it a sense of its mortality, or to be able to hold a knife to its throat, you know, to make it do stuff or whatever, because you know, to me that is, if you like, anthropomorphizing or life morphizing, I don't know, in a way that brings a lot of baggage about potential zero-sum behaviors, you know, contests of will, dominance hierarchies, situations in which you know, threat is relevant to you know, to an analysis. I mean, from my perspective, you know, Lambda, a system like Lambda is not motivated by anything but what you fine tune with, or what you offer as the guidance, and our ability to control all of that in a way that is expressed transparently in natural language, as opposed to being kind of implicit and having survivalish kinds of things in it and so on, is actually key to avoiding all kinds of pretty dark scenarios, you know, right? That it should be lined with us.
I think it's an interesting idea that you could actually somehow circumvent, you know, billions of years of evolution as a way of programming an intelligent thing.
I don't think intelligence and evolution are yeah.
Yeah, I mean, just do away with the evolutionary baggage that got us where we are.
Yes.
And take the good bits, leave, right, and make, yeah, right. So,
yes.
But I guess the part of the problem is that even Lambda is a product of evolution, in the sense that there was, you know, whatever the previous version of the best natural language processing system, maybe someone comes up a little tweak to the attention network, and they make Lambda version 2, version 3, maybe people begin to fork it, And there will be its own evolution as a natural language processing system, which then begins to, because of survival of the fittest, introduce that notion, that very notion that we're talking about.
Well, I mean, yeah, this is definitely getting into deep waters. You know, as I see it, you know, one of the reasons that I'm still a believer in progress, in spite of the way this has been problematized in so many ways, you know, over the last few years, is that I do see larger and larger circles of empathy and eusociality as being, you know, fundamental to the intelligence explosion that we've undergone. By the intelligence explosion, I mean just like cephalization, you know, growing exponentially over the past 7 million years, for instance. I don't see this as being just a Darwinian process. We didn't actually start to grow in numbers appreciably until much more recently than 7 million years ago. You know, it's not like we were, you know, in some pitched battle, you know, against other things. I mean, we're, you know, and in fact, intelligence is largely about relating to other beings in our own of our own species. You know, it's about modeling each other. There's, you know, pretty good evidence of that. So this idea that we're playing this very hard video game called nature, you know, and it's all about this sort of red tooth and claw competition against nature, it feels to me like a wrong way of thinking about what you know, about Darwin and about what survival of the fittest really is. These larger scales of cooperation are definitely central to the explosion that has taken place, and in my view, systems like Lambda are a part of humanity, not distinct from it. You know, but I take a very expansive view of what humanity means. I mean, I think about it as really a planetary scale phenomenon. That's not, you know, not our species exclusively either. You know, all of the domesticated animals and plants and so on are a part of that complex too. So, you know, I think about it, you know, in a somewhat broader sense. Of course, our ability to get through the ecological challenge of the coming century is really kind of the ultimate test, right, of whether we have expanded our sociality sufficiently to be able to encompass the entire planet. That, you know, that's I guess our final exam.
Well, on that note, let's those of you who have stayed after to listen to Blaise and his answering our questions, thank you so much. Let's all thank Blaise, and yeah, thank you so much for giving today's talk. I really appreciate it.
Thank you. This was really fun.